So let's go ahead and do this problem 4.44. It is believed that nearsightedness affects 8% of all children in a random sample of 194 children. 21 are nearsighted. So this is our first hypothesis test we're looking at. Notice I'm in my hypothesis testing tab. We have several different choices for hypothesis testing, many different choices. We've got one mean, we've got one mean if we only have the stats as opposed to the data. We've got one mean for proportions, we've got two means, we've got all kinds of stuff. But this is the one we're going to be dealing with. This is a proportion that we're finding. We want to know the percentage of people, percentage of kids who are nearsighted. So we take 21 and divide it by 194. And that gives us our proportion. So the number of successes is 21. Our sample size was 194, and we take those two and the computer divides them for us to find our p-hat. So our p-hat is about 11%. We want to construct a hypothesis test for the following question. Do these data provide evidence that the 8% value is inaccurate? So what we're going to do is we're going to say, if it is really 8%, how likely is it that we would have gotten 11%, which is what we did get? And if it's really likely, then 8% is fine. And if it seems like it's almost impossible that we would have gotten 11%, then the 8% is wrong. We have to reject that 8%. And I'll say that again in a minute. Anyway, so from our sample, these two numbers divided by each other, we get 11%. Our null hypothesis, or our null proportion, is 8%, so I'm typing it in there. The z-score is calculated for me. I'll go ahead and type out the computation for that, so you can see that if you'd like to see how to do it by hand, because you have to do it by hand in your first project. And we have these three different p-values here. These are the probability that we get 11% given that the true proportion is actually 8%. So we have a two-tailed test, so this is about 15% probability. We've got a left-tailed test, which is a 92% probability, and we have a right-tailed test, which is a 7%. Notice that these two added up give you 100%, right? We have to figure out which one of these to choose, because we can't use all three of them, we're only using one of them. So do these data provide evidence that 8% value is incorrect? So not that 8% is bigger, or that a value is bigger than 8%, or that it's less than 8%, but actually that's just not equal to. So this is the correct choice here, and this is telling us we're dealing with a two-tailed test. So we're going to use this number, 1.4699, or if we round it to 4 decimal places, it's 1.470, right? Oh, it says 71. Oh, that's very confusing. I don't know how much that matters. Is there something wrong with my calculator? Anyway, this might be an issue. What's it say? Well, that sounds fine. They might be getting this p-value directly from a z-score table. Anyway, we'll see if that's an issue. Maybe there's something wrong with my calculator. Don't think there's anything wrong with my rounding. I think that's fine. Anywho, what does this number mean? This number means that there's about a 15% chance that we would get our sample proportion of 11% if the real proportion out there is 8%, right? Because it's possible that we just happen to walk into a classroom or a school with slightly more, we asked a couple extra nearsighted kids, and the real proportion is still 8%. So a 15% chance of that happening, a 15% chance of our proportion being 11%, if this one is right, is fine, right? We have chosen an alpha. We haven't chosen an alpha, but if there's no alpha given to us, we assume that it's 5% or 0.05. And so this number is much larger than 0.05. So 0.05 is our cutoff. If this probability had been 0.04, we would say, oh, it's unlikely that we would have gotten this percentage if this was 8. But since it's not, since it is likely, it's 1.1470. We can now select which one we're doing here. So the probability of success was about 15%, which is bigger than alpha. So now we've done these choices, right? We do not have enough evidence to reject the null hypothesis, and this is what we're going to choose. This one is tempting here, right? The probability is greater than alpha, so we accept the null hypothesis, but we don't actually ever accept the null hypothesis, right? We We just don't reject it. We're like, okay, it's fine for now. It'll keep working, but we'll test it again later. Yep, that's cool. All right, we got that too. That's great. This is weird. I don't know why this is happening. If you're having some issue here, post in the forums. Let me know. All right, that's it. If you have any more questions on the hypothesis test, let me know. I'll show the computation for the z-score down below, which will include the standard error also. Okay.